Welcome to Differential Equations, section 3.6. We're going to do activity 361. It's a little blustery outside, so hopefully it doesn't affect the sound too much. Now this problem, we have the same matrix from activity 321, which, if you might recall from that section, had some ugly eigenvalues and eigenvectors. And that's going to give us a lot of work to do. So buckle up, because we're going to do a lot of algebra here. I'm going to do it by hand. I don't know why. Maybe because I'm a glutton for pain or something. All right. Now, our first job is to find the eigenvalues. One minus lambda, -1, -1, 2 minus lambda equals 0. So then that means you got 1 minus lambda times 2 minus lambda, and then minus negatives times each other is +1. Minus that, so -1 is 0. So then you get lambda squared minus, there's -2 lambda there, -1 lambda there, so -3 lambda, and then +2, but -1, so +1 equals 0. And so then we'll do the quadratic equation, lambda equals -b plus or minus square root b squared minus 4ac all over 2a. The lambda equals 3 plus or minus square root of 5 all over 2. Okay, so we'll call lambda equals 3 plus square root of 5 over 2, and mu equals 3 minus square root of 5 all over 2. Okay, now let's find those eigenvectors. So if I subtract that from the diagonal, I have 3/2, so 1 minus 3/2 is -1/2, then that's minus as well. 2, and I made that bracket not nearly big enough. And then I've got -1 and -1, and then 2 minus this is a +1/2 minus square root of 5 over 2. And then this option over here, the same, but you just got the square root of 5 is minus and negative is positive. So -1 plus square root of 5 over 2, and -1, and -1, and 1 plus square root of 5 over 2. All right, so now let's think about the Kyle numbers. Well, it's nice that I have a -1 here. So if I have a 1 here, and I copy this term right there, then I'll have 1 times it plus -1 times it. So -1 minus square root of 5 over 2 are my good Kyle numbers. Similarly, got the -1 there, the same thing applies. So the vector here is 1, and then -1 minus square root of 5 over 2. And the eigenvector here would be 1, and then -1 plus square root of 5 over 2. All right, it's not an accident that these are both kind of the conjugates of each other. They're just the same except for positive and negative square root of 5. Okay, so now we have our eigenvectors. So we create a matrix T. T equals 1. We'll just choose to go lambda first, then mu. You can do it in any order you like. You just got to stay consistent. T equals -1 minus square root of 5 over 2, and 1 -1 plus square root of 5 over 2. Okay, now we got to find the determinant of T in order to find because we want to find the inverse. So the determinant of T is that term minus that term. So -1 plus square root of 5 all over 2. Subtract this makes both the terms positives, plus 1 plus square root of 5 over 2. So -1 and +1 cancel out, and I get That's square root of 5. So T inverse equals 1 over the determinant, 1 over square root of 5, times, and then you swap the diagonal, -1 plus square root of 5 over 2 and 1, and then make the off diagonal negative, -1, and these are both negative, so it becomes 1 plus square root of 5 over 2. Okay, so then let's multiply that through. So then we get here, we're going to get negative, let me split these two fractions up a little bit. So then think about this as like a 5 to the 1/2, -1/2. So -5 to the -1/2 plus 1, square root of 5 divided by square root of 5 is 1, all over 2, and then negative, then this is going to be square root of 5 over 5, and this is going to be similarly 5 to the -1/2 plus 1 all over 2, and positive square root of 5 over 5. And we move to a new page. Simplify that. So if you're kind of lost with the algebra there, I just recommend doing it yourself. Everyone's got their own favorite way to divide by square root of 5. Okay, and so then here, I'm going to multiply top and bottom by 5. And so that gives me, multiplying this one by 5 gives me negative square root to 5 minus square root of 5 over 10. And of course I need that more. And then I've got 5 plus square root of 5 over 10. And then negative square root of 5 over 5 and positive square root of 5 over 5. That's T inverse. Okay. Another way to write T inverse that avoids fractions would be that T inverse is 1/10 times the matrix 5 minus square root of 5, 5 plus square root of 5, -2 square roots of 5, 2 square roots of 5. That way it avoids fractions, and that'll help us to avoid fractions in the coming multiplication, because now we're asked to find T inverse AT. That's equal to 1/10 times 5 minus square root of 5, 5 plus square root of 5, -2 square roots of 5, 2 square roots of 5. Recall that A was 1, -1, -1, 2, and that T was 1, -1 minus square root of 5 over 2. I feel like I could have taken the 1/2 out of this one. That'd make it nicer too. 1 over -1 plus square root of 5 over 2. Okay. What I'm going to do in the next step is I'm going to combine these two. I'm going to take the 1/2 out. Okay, so 2 steps at once. So I have 1 over 20 times, multiplying this together, I've got 1 times 5 minus square root of 5 plus 2 square roots of 5. So 1 minus square root of 5 plus 2 square roots of 5 is 5 plus square root of 5. Okay, And then 5 plus square root of 5 minus 2 square root of 5 would be 5 minus square root of 5. And then 5 minus square root of 5 times negative 1, which should be negative 5 plus square root of 5. And then minus 4 square root of 5. So negative 5 plus square root of 5, so negative 5 plus negative 5 plus square root of 5 minus 4, so minus 3 square root of 5. And then multiplying this row here, so negative 1 times this would be negative 5 minus square root of 5 plus 4, so negative 5 plus 3 square root of 5 times this matrix, and I took out the 1/2, so now I've got 2, negative 1 minus square root of 5, and negative 1 plus square root of 5. Okay, so then this equals, I still got my 120 out here. And now, things get a little hairy. I'm gonna have to do it in a little more steps. So now, let's see. So does that look correct? Yeah, the negative 3, the negative 5, the positive 3, the negative 5, the positive 5s, the positive and negative square root. Yeah, that looks good. Okay. So now I've got 2 times this guy plus these two guys multiplied together. So 10 plus 2 square roots of 5. And then I'm going to make, these are both negative, those are both negative. Just take factor negative out of this one and negative of that out of that one. So then plus 5 plus 3 square root of 5 times 1 plus square root of 5. Okay, I didn't leave enough room on my paper. So maybe I'll restart just so I can fit everything in. Hope that's okay with you guys. Yeah, so I'm gonna restart over here. More room. All right, 120, so 10 plus 2 square root of 5 plus 5 plus 3 square root of 5 times 1 plus square root of 5. All right, and then the term in the first column, second row. So forget about this. All right, so then I've got that times that. So 10 minus 2 square root of 5 times this. So if I factor out the same thing as last time, if I factor out the negative 1 from here and the negative 1 from here, I get 5 minus 3 square root of 5 times 1 plus square root of 5. And then here, you got the same top. So then you still get the 10 plus 2 square roots of 5, and then that times that. So then it's just a minus on the square root there. Because if I factor out negative 1 and negative 1, I get plus 5 plus 3 square roots of 5 times 1 minus square root of 5. And then here you got 5 times that, so 10 minus 2 square roots of 5. And then plus, this time I've only got 1 minus and 1 minus, and won't factor anything out this time. I'll just do 3 square roots of 5 minus 5 times square root of 5 minus 1. Okay, now it's time to simplify. I mean, luckily I don't have any fractions, so that's nice. Okay, so let's multiply some things out. So I've got, let's think about what numbers I have. So I've got 10, and I've got plus 5, and this times that was 15. 10 plus 5 plus 15 is 30. Okay, how many square root of 5 terms? Here's 2 of them, and then 3 more, and 5 more. So then 2 plus 3 is 5, plus 5 is 10 square root of 5. Okay, that's looking good because my original eigenvalue is 3 plus square root of 5 over 2. So if I take this divided by 20, I get 3 plus square root of 5 all over 2. That's nice. Now let's look at this one. My numbers terms, 10, and I've got plus 5, but then there's a minus there, so minus 15. 10 plus 5 minus 15 is 0. How many square root terms? So I've got 2 square roots of 5 here, plus 3 there, so it's 5, then minus 5, so 0. Okay, similarly, this term will hopefully be 0. So I've got 10, and then plus 5, minus this times that will be 15, because it'll be 3 times 5. So that'll be 0 for there, and then how many square root of 5 terms? Negative 2, minus 3, plus 5, so 0. And then here, I've got 10, and how many number terms do I have? 10, and this plus that, this times that will be 15. 10 plus 15 minus, no, plus 5, so that's 30 again. And then my square root terms, I've got negative 2, negative 5, and negative 3. So minus 10 square roots of 5. Okay, well that's equal to 3 plus square root of 5 all over 2, 0, 0, 3 minus square root of 5 over 2. And we did it. We did it in only 2 pages. What do you know? I also have some Sage I'll share with you guys for those who don't like doing tons of algebra paper. It's really good. It's kind of cathartic in a chaotic life, chaotic time to just do a bunch of algebra that ends up working out. Okay, where are we at? I found T inverse AT. So the general solution is, okay, so now I've got my general solution. So the original system is in terms of x prime. And now I've got a solution in terms of y prime. So recall what my data is. My data is A is 1, negative 1, negative 1, 2. And basically, I found that if I've got lambda equals 3 plus square root of 5 all over 2, mu equals 3 minus square root of 5 over 2, and that if t equals the eigenvectors 1, 1, negative 1 minus square root of 5 over 2, and 1, negative 1 plus square root of 5 over 2, then this new, so I have x prime equals, as a vector, equals a times the vector x. And if I define this new vector, y equals tx, then y prime will equal y prime will equal t inverse y prime equals t inverse a t. Wait, maybe it's if x equals ty. So I'm looking for this y that's sort of x equals ty. So then y prime equals t inverse at y. Okay. So then, do you want me? I think if I were in class right now, I could imagine a student having a question. So let's back up a little bit. X prime equals ax. Okay. So then let's say, well, let's let y equals t inverse x. So we have a system that has this solution, has this differential equation. Well, I can come up with a new system that's t inverse times that system. Okay. So it's just a linear transformation of that system. Well, in that case, then if you take this system, you multiply by t, then you have so t times y equals x, because the t and t inverse will cancel out. And then if you take the derivative of both sides, x and y is a vector. Okay, but x prime is equal to ax. So that's kind of the thing about x. Okay, well, that means that ty equals a, and x is really ty, right? So then multiply by t inverse on the left, you get y equals t inverse aty. Okay, but this thing is a diagonal matrix. So instead of being like a system, it's just two different variables that are completely independent of each other. And so then you know how to solve that system really easily. And so then we know that y as a vector, think of it as being y1, y2. We know that y1 is going to be c times, solving for y1, the general solution would be c times e to the lambda t, where lambda is that thing, I'm just too lazy to, lambda is that eigenvalue, I'm just too lazy to write it down because it's big, and y2 equals c e to the mu t, where mu is the other eigenvalue. And then, well then x is just equal to t times y. So then if you just t times that, you get x equals, let's see one, let's see two, the different constants. That's important because they're both created independently. So then x is t times that. So then x equals c1 e to the, I'll write down the lambda this time, e to the 3 plus square root of 5 over 2 times t times the vector 1, and then negative 1 minus square root of 5 over 2 plus c2 e to the 3 minus square root of 5 over 2 times t times that eigenvector 1, negative 1 plus square root of 5 over 2. Oh, you can't see that. Okay. So x, the general solution is that plus that. So it's c times e to the eigenvalue times t times eigenvector plus unknown constant 2 times e to the eigenvalue times t times eigenvector. Okay? That completes our activity.